This is a test review for test 1, and I want to note that while I'm going to try and hit on every type of problem that we've covered in Module 1, you should probably go back over some of your quizzes and review more than just what I'm going to cover. This will just tell you the various different types of problems, but Module 1 was fairly large and it was all review for you. It should have been things you had covered in previous courses, and so as such, there's no time to do every single problem in a test review, but this should hit some of the high points and give you a heads up about things that you're not sure of. One thing I would tell you to do first is go through and work the test review before you listen to this video. So if you haven't done that, stop the tape now and go and do that, and then come back and see if you have any questions afterwards. And like I said, go back over and do the online review as well, and go back through your quizzes before you take the test. The first problem is really just showing an equation and asking us to solve it, basically. And we have two sides to an equation. The first side over here on the left has two terms that are not like terms. There's not much we can do there. But over on the right, we can distribute multiplication. So I'm just going to bring down my left side. And I'm going to say negative 4 times 2x to give me a negative 8x. And negative 4 times negative 4 to get a positive 16. The next thing I'm going to do is try to get all my x variables on the same side, all my unknowns together. Now you could do this one of two ways. I always choose to work with the smallest variable that I've got, and negative 8x is smaller than negative 3x. So I'm going to work over here and see if I can get this one to go to the other side. Of course, the opposite of negative is a positive, so I'll add. Instead of subtract, I will add. At this point, all we can do to get from one side to the other is add or subtract. And these will, of course, cancel each other out. There'll be 0. And when I say 8 minus 3, I come up with 5x. There's my equal. I have to, of course, bring down my negative 14. And that was a positive 5x. And over here, I only have 16 left. Now, I want to get rid of this negative 14 because I need to isolate the variable term. So since it's negative, I will add 14. Remember, at this point, all I can do is add or subtract. So I end up with 5x on the left, and this is equal to 16 plus 14, which is 30. And the final step, if there is one, if you have a coefficient in front of your variable and you've only got one term on the other side, then you divide by the coefficient, whatever it is. 5 divided by 5 gives me 1x. 30 divided by 5 gives me 6, and my solution is x is equal to 6. The next problem requires me to do some distribution of multiplication. Remember, this time I'm distributing a negative 7. Remember that you have to multiply times you have to keep the sign that's in front of the term with it. So this is a negative 7. I will distribute it to both terms inside parentheses, but this is an inequality. So I'm going to end up graphing this and writing it in 3 different notations, just as we did in your homework. Let's do the distribution first, though. Negative 4 is not really affected in distributing this negative 7, so I'll just bring it down. And then I'll say negative 7 times negative 4 gives me a positive 28. And then negative 7 times a positive 2x is going to give me a negative 14x. And I'm going to bring down my inequality sign and my 122 over here on the right. Then I need to combine like terms over here. I need to do all this until I can get to just one term on each side. Right now I have a negative 4, positive 28. That'll give me a positive 24 and a negative 14x. And I've still got my same inequality sign. And then I want to isolate this variable term. So I got to get rid of this positive 24. I'll use a negative 24 to do that. I'll subtract 24 from both sides. And don't forget, when the term in front of it disappears, the negative sign does not go away with it, right? This is a negative 14x. It is greater than or equal to, and the math here is a little bit different. You might use a calculator, but it's 98. That's what it is. Finally, I've got to get down to just 1x, and this is a negative 14, so I'm going to have to divide by negative 14 to get there. So I'll have to divide both sides by negative 14, and this is where we must do something that is a little bit unusual, only happens with inequalities. When we divide both sides by a negative, we flip the inequality around. So I'll have a positive 1x, and I'll have a negative, and really, I've got 98 divided by 14, or 98 divided by negative 14 is going to give me a negative 7. So how does this look on a number line? Well, put your number line out here. It goes to negative infinity on this side. It goes to positive infinity on this side. I'm going to put 0 on it. And negative 7. Those are just 2 points that I know where they are. I just want to make sure I get 0 so I have the negative in relation to it. And then since x is over here on the right, I can point my arrow that I'm going to graph in the direction of my arrow in the inequality. In other words, I start at negative 7 and I'm going to go this way. And I'm going to keep on going because it's everything less than or equal to. When I say equal to, this is the type of bracket I use, that square bracket. It says it might be equal to the point negative 7, everything less than. And let's write it now in set notation. We write the smallest number that the solution can be. Well, it reaches, if we go over to the left, it gets as small as negative infinity. That always uses a curved bracket. And the biggest it can ever be is negative 7. And since it can reach negative 7, we will use the square bracket. Now, how would we write this? How would we write this one if we had a three-sided inequality? Well, first, we've still got to do the same thing. We've got to get x isolated and in the middle of this inequality. So we have to do the same thing to all three sides. When we have two inequality signs, we have three sides. So first I want to get rid of this 1 that's getting confusing things, and I'll subtract it from all three parts. I'll just draw lines to show I'm doing that. That's 5 minus 1 is 4. Bring down my inequality sign, and this is a 4x in the middle because I got rid of my 1. And I'll bring down the inequality sign, and this is 41 minus 1, which is 40. The next thing I do is I look at my variable term. Yep, it's been isolated. It's all alone. So I can now divide by the coefficient. All three terms must divide by the coefficient. 4 divided by 4 is 1. I don't change the sign because I divided by positive, right? 4 divided by 4 is 1 again. And here I've got 40 divided by 4, which is 10. Now, I want to look at what this looks like on a number line. So I'm going to draw my number line. Important numbers here are 1 and 10. Let's just go ahead and put 0 in, and we'll put 1 right here, and we'll put 10 over here. It doesn't have to be to scale. I'm going to say this goes to negative infinity, and this goes to positive infinity. And x is greater than, see how I'm reading it backwards here. I'm saying x is bigger than 1. So it goes this direction. It's also smaller than 10. Now, does it equal 1 and 10? There's an equal on both of them. So I'm going to put the hard brackets, the square brackets with both of those, and I've graphed it on my number line. All I have to do now is write it in set notation. Set notation says what's the smallest value x can be is 1. What's the largest? 10. And now you have to just put the correct type of brackets. And all that means is the square brackets we use when there's an equal sign, and the soft brackets or the curved brackets we use when there's not. The next one, it really says solve for b. And this problem can be worked so many different ways, but it does have a fraction in it. And when it has a fraction and an equation, we clear the fraction by multiplying every term in the equation times the common denominator. Least common denominator for all fractions. Well, there's only one fraction. So in this case, our LCD would equal that denominator of 2. So I'll multiply times 2 over here. And over here, I'm going to get in the way a little bit. I'm going to multiply that times 2 also. And when I do that, you could write it as 2 over 1. I will cross-reduce those 2's. I don't have to multiply in these parentheses because I'm already multiplying times. I'm distributing this c over 2 times that. So that's already taken care of. I just had to multiply it times each, the term on the left and the term on the right. So now I have 2 times r is equal to, and these actually reduced, so it's just plain old c times a plus b. I got rid of my fraction. It's a little easier. I still need to solve for b. I'm going to go ahead and distribute the c. So 2r is equal to c times a. Well, that would really be written alphabetically, and c times b. Now, I still need, this is the term I want to isolate. so I need to get rid of this one. It's a positive AC, so I'll just go ahead and subtract AC from both sides. And now I have BC over here on the left, and BC is equal to, let's just write it out, 2R minus AC. So what do I have to do still? Well, I need to solve for B, which is multiply times C. The only way to get rid of that is to divide by C, which I can also do on this side, divide by C. When I divide by C, over here on the right it disappears, and I truly have B is equal to 2R minus AC over C. I'll rewrite this for you. B is equal to 2R minus AC all over C. Now look at it and make sure you understand that these two C's cannot reduce because of this subtraction. If everything was multiplied times each other in this numerator, then we would reduce the C's. But we can't reduce those two C's unless they exist in both of these terms that are in the numerator, and they don't, so we're stuck with it. Let's look at the next page. And this one is an example of a word problem that we looked at in your homework section. It's asking the price of a television before taxes were paid on it, and the price of the TV plus the tax was $490.50, and we know the tax rate. You have to remember that when we're adding tax, we take the original price, and then we add to that the original price times the percentage of tax, right? That's how much tax you pay. And that's equal to the final price that you pay. I just write down this quick little formula to remind myself that I've got the original price plus the original price times the tax rate, the percentage, and that's going to equal what I have to pay. Now I know some of these things. There's only 1, 2, 3 unknowns. Original's in there twice, but it's still only one unknown. And that is the price of TV before tax. So that is my unknown. I'm going to go ahead and put X in for that. And this is times the tax rate. Well, the tax rate's 9%. Be careful doing this. You want to make sure to write it as a decimal. And sometimes that gets tricky. And then the final price, well, they gave me that too, $490.50. So all I have to do over here is add these two X values. Well, this is 1X and this is 0.09X. That's easy to add, isn't it? 1 plus, well, I'll write it like this, plus 0.09, right? So it would just be 1.09. So I have 1.09X, and that's equal to 490.5. And then I can divide by the coefficient, which is 1.09. You can do this easily with your calculator. And when you do, you find the original price. That's the unknown. And 490.5 divided by 1.09 gives me 450. Be sure you write the dollars there because it is a word problem and we need the units, and it was in dollars. It was the price of the TV before tax. So let's look next at identifying in 6. Let's identify the slope and the y-intercept in this problem. Now, of course, you can see that it's already in y is equal to mx plus b format. So when we have that, we have the slope. The slope is the coefficient of x. So it is a negative 5 over 3. The y-intercept is going to have the y-coordinate of the point is going to be 3. But for every y-intercept, x is always 0. So you don't have to have that in your equation because you know it has to be 0. And that would be the slope and the y-intercept for that linear equation. Let's take another equation. This is also a linear equation. It is a straight line, but if they ask you for the point and the y-intercept, you can't find it. You have to solve it for y. So we need to get rid of this 7x. We'll subtract it from both sides. And that gives us a negative 2y equal to a negative 7x plus 8. I'm always trying to get it into y equals mx plus b format. That's why I wrote the negative 7x first. Now all I have to do is divide everything by the coefficient of that y term. I have 3 terms, so I'll divide them all by negative 2. And I end up with y is equal to, well, this is going to be a positive slope, isn't it? 7/2, and I'll just put it in front of the x. And that's going to be 8 divided by negative 2, which is a negative 4. So now I can identify my slope. My slope is 7 over 2. My y-intercept is going to have a y-coordinate of -4. And of course, the x-coordinate for a y-intercept is always 0. Now let's take a look at an equation that is actually given to us as a function, and it's given to us as the f of x. f of x is equal to 2x squared plus 7x plus 1, and they've asked us to find f of 3. So what they've told us is that x, see, x fits right in there, x is actually equal to 3, right? That's what this tells us. And what they want us to do is to find y. Because f of x here, we could substitute in y is equal to 2x squared plus 7x plus 1. So I'm going to write it like this. I'm going to say f of 3, the function of 3 is equal to 2 times 3 squared plus 7 times 3 plus 1. And now all I have to do is do the math. I'll square this first because that's order of operations, and I'll have 2 times 9. I can come over here and go ahead and multiply this together since it's a lower, separated by a lower operation. And now I'm going to just kind of finish this up. And all I have to do now is just add these 3 numbers together, and I'm coming up with 40. So if x is 3 and y, I've just found, is 40, the solution to f of 3 is the point 3 comma 40. In other words, where on the line is x equal to 3? Well, the y-coordinate would be 40. Next, I want to take really these are just very complicated terms, aren't they? And multiply these two terms together. Some of them using negative exponents and coefficients. And let's just see if we understand how to do this. So I've got multiplication here with these two terms. Let's look and first do the coefficients. I would say 3 times 3 first, and that's going to give me 9. So I took care of multiplying. I'm just going to try and draw a line so you see what I'm doing. I took care of multiplying those two together. The next thing I'm going to multiply is going to be this x term. I'm going to say x, or this x variable, x here times x here. Well, this is -4, and this is exponent of -4, this is exponent of 3, and when we have the same basis, we add them. I'm going to end up with an x to the -4 plus 3, which is going to be -1. I'll just write it down for now and figure this out later if it needs to move. Next one, do I have y's in both of these terms? And I do. Y to the 4th times y squared. Well, I will add those exponents and I get y to the 6th. And then I have nothing to multiply z by, so it's just really times 1. So I've got z cubed. Now the only thing wrong I've got is I can't leave a negative exponent. To resolve it, I would take this to the other part of the fraction. I'm just going to circle it so I can tell what I'm going to take down. This has to move down to get to be a positive exponent. So in the numerator of my new solution, I will have 9, y to the 6th, z cubed. In the denominator, x to the power of 1, which is just x. Okay, the next one, next page. Let's look at number 10. This one is really looking to see if we know how to handle these exponents. When an exponent inside parentheses, something is raised to another exponent, well, we have to take each variable and raise it to the power of 2. Don't forget the coefficient. We first take 2 and raise it to the power of 2. Well, that's going to be 4. That's the most important thing to not miss. That's commonly missed. Now I'm going to take x cubed and raise it to the power of 2. And when I'm raising an exponent to a power, that's when I multiply the exponents. 3 times 2, 6. Now I'm going to take y to the -3 raised to the power of 2. Well, I multiply. This time it's going to be negative, isn't it? -3 times 2, -6. And z to the -4 times 2 is going to give me z to the -8. I still have some work to do. I'll go ahead and write this second term down. At least I've already taken care of raising everything to a power that needed to be done. Now at this point, I can go ahead and do the multiplication like we did on the other side, on the other page, or I could go ahead and put these exponents where they belong. I'm going to choose to go ahead and do the multiplication like we did it on the previous page. So I'm going to say 4 times 2 gives me 8. And then I'm going to go x to the 6th times x to the 4th. X to the 6th times x to the 4th, I add those together and I get x to the power of 10. Y to the negative 6, I don't have any y's over here, so I'll just have y to the negative 6. I have z to the negative 8 times z to the 4th. Well, I'll add those two together and I'll end up with z to the negative 4. Now, 2 of these need to go down to get resolved to stop being negative exponents, so I'm going to leave 8x to the 10th in the numerator, and I'm going to move y to the 6th, z to the 4th down. The negatives down, they become positive when they go down. Now, this one I've got to do the same thing basically, but this time I'm cubing it. So let's look at raising exponents to powers. Y to the negative 4 times 3 gives me y to the negative 12. That's the numerator. Denominator, 2 to the power of 3. Well, that's 2 times 2 times 2, or 8. Y to the 1 times 3 is y cubed. X to the 3 times 3, x to the 9th. The only thing I've got to change now is I've got to get these y's together. I need to take this down anyway. When I do that, I'm going to have 8. Yeah, well, I'll just show you what will be down here. 1 over 8 y cubed times y to the 12th. I moved it down, it became positive, times x to the 9th, which I can also write 1 over, let's combine these two, okay? And add them together. Y to the 15th, x to the 9th. Now, scientific notation means that we have to move our decimal to where there's just one significant digit in front of it. And that would make our number here come out to be 2.1 times 10 to the power of something. If I take my scientific notation and I want to get back to standard notation, the original, I would have to move it in a negative direction, right? I would have to move it a negative 1, 2, 3, 4 places. So the exponent would be negative. You can look at it like that, or you can say, well, this is a really small number. It's much smaller than, than 1, so it's going to have a negative exponent. Let's do some math with these exponents next. Let's take, the first thing we're going to do is multiply the number term in front of the scientific notation. Let's multiply those together, and let's say 3 times 3 times 6, 3.3 times 6.5, and I did it, and I came up with 21.45. And that's going to be multiplied times, let's do the 10 to the power of next, times 10 to the power of, and same base, adding exponents, I'm going to end up 10 to the power of negative 2. But this is not in the correct scientific notation. The decimal has to be moved again. In other words, I'm going to have to move that decimal to 2.145, right? So what do I actually have to do? Well, I actually had to add a decimal place. If in essence, it's going to have one more. So I'm going to end up with times 10 to the, this time, negative 1. Next, I've got two binomials that I want to multiply together, and you'll recognize this as a FOIL problem. So I'm going to come down here and say the first terms multiplied together, 7x times 2x would give me 14x squared. And then I'll do outside terms, 7x times 5 is going to be a positive 35x. We have all positives here, but be sure you watch the signs on these. Inside terms, 8 times 2x, a positive 16x. And last terms, 8 times 5, a positive 40. When we FOIL, we can look for outside and inside to match. The others we just bring down. I say 35x plus 16x, 51x. It's a positive 51x. And I bring down my third term. And it ends up being a trinomial. Now, what happens when we square a binomial? Well, remember, this one does have a shortcut to it that if you remember it, you can use it. If not, you're going to have to FOIL it, but you will have to write it again to FOIL it. So I'm going to write it as 5x minus 4 times 5x minus 4. And then I'm going to say, first terms, 5x times 5x was 25x squared. And then I have to go outside terms, 5x times negative 4. This is tricky. You have to really watch the negatives. 5x times negative 4 is a negative 20x. And then I'm going to do inside terms. And I go negative 4 times 5x, another negative 20x. And last terms, negative 4 times negative 4, positive 16. When I look at my inside and outside terms to combine them, I have 25x squared minus 40x plus 16. Now, if you want to remember the pattern for this one, this is it. You would take this first term and you would multiply it times itself or square it. It would be 5x times 5x or 25x squared. Take the last term, which is a negative 4, and square it. Negative 4 times negative 4 is positive 16. And then for the inside terms, you would simply multiply the two terms together. You would get negative 20x, and you would double it. Negative 20x plus negative 20x is a negative 40x. If you remember that shortcut, you can go directly to the answer. Be sure you're remembering the shortcut correctly, though. Otherwise, just FOIL it. Now, the next one we've got is a binomial times a trinomial. 2 terms times 3 terms. We're going to have to multiply 6 times and then combine like terms, basically. So I'm going to take this one little step at a time. I'm going to say 3x times 2x squared, and I'm going to come up with 6x cubed. Then I say 3x times the next term, which is a negative x. Well, that's going to be a negative 3x squared. And then 3x times positive 5, which will give me a positive 15x. And I've taken care of multiplying 3x times all three of these. Let's do the same thing with 5. 5 times 2x squared. That's going to be an x squared term. I'm going to write it under this one. And it's a positive 10 when I do the multiplication, so I'll write it. Positive 10x. Then I go 5 times a negative x. Well, that's going to be an x term. It's a negative 5x, isn't it? And then I go 5 times 5. There's no just plain numeric term, so this will be out here by itself, positive 25. And now I can draw a line and combine these terms. Positive 25, and I combine 15 and negative 5x's, and I get a positive 10x. And then I combine 10x squared and negative 3x squared, so I get a positive 7x squared. And I have nothing to combine with the x cubed term, so I just bring it down. So what about division? This is this trinomial divided by a single term. Well, remember how we split that into 3 different fractions and just reduced them. So I'm going to have 3 fractions, and for my fractions, the denominator is all going to be 10x squared. And I'm going to separate these things with addition. No matter what the signs are, I would always do that. And handle the signs later. Now, the first term goes over this one, 4x cubed. The second one over the second one, 30x squared. And the third one, 5x, goes over my third one. Now, all I have to do is one at a time just reduce them. 4 over 10, well, I can divide both of those by 2, can't I? 4 divided by 2 gives me a 2. And 10 divided by 2 gives me a 5. That's lowest terms. And then I say x cubed, x squared, I subtract them. I have x to the power of 1. Where is the bigger denominator? In the numerator, so that's where my answer goes. Plus, this one, the x squared over x squared just reduces. And actually, I could also do this and say, really, well, you could just say 30 divided by 10. What is it? 3, isn't it? Now, let's say this is going to be plus this third one. Now, 5 over 10 is the same as 1 over 2. And x over x squared, I would subtract them and have x remaining in the denominator, because that's where the bigger exponent was. Let's do the same thing, but this time we're looking at synthetic division, because we have a polynomial that we're dividing by a binomial, and it just has a single coefficient is 1 out here, and that's okay. We can do that. And it doesn't have an exponent. It's just a simple binomial, right? So now the first thing I'm going to do is say I'm going to be dividing by the opposite of whatever the numeric term is. It's a -6, so I'll divide by a +6. I'm going to draw the block upside down because this is synthetic division. And I'm going to look at this problem. A cubed, a squared, a, and just a numeric term. I'm okay with those. I don't have to add any extra terms. So the coefficient's all I need. The coefficient of the first one is 1. The next one is -14. The third one is a +54. And the fourth one is a -28. Step 1, bring down the first term. Now multiply. 6 times 1, +6. And combine these two. -14, +6 is going to give me a -8. 6 times -8 gives me a -48. Combine these two. 54 minus 48, well, that's a +6. Multiply 6 times 6, +36 over here. And when I subtract 36 minus 28, I'm going to get 8. Now, those are my answers. I look at my problem. I started with an a cubed. I have to go 1 degree less than that, so I will have an answer that will be a squared. 1a squared. I can just write a squared. And then minus 8, a, and plus 6. Those are all of the terms I can use. And this last one must be a remainder. I write it over the divisor, a minus 6, and that is my answer.